Hi everyone. I'd like to work on one last example of applications of exponential functions. Okay, so a new car is valued at $20,000 and will depreciate to $17,000 in 1 year. We are supposed to figure out a couple of things. The first one is if the value is decreasing linearly, what is the annual rate of decrease? So if we drop from 20,000 to 17,000 in 1 year, and we assume that that's going to continue with a straight line pattern, so this is 20,000 and then it's dropping. What is the annual rate of decrease? Well, I know that up above, the annual decrease for the brand new car within 1 year was $3,000. If this truly is linear, that means that slope of 3,000, so it's a slope because this is per 1 year. So there's our rise over our run. And I think I'm being a little bit backwards. This went from 20,000 to 17,000, which means I should technically switch this. The slope is negative 3,000. Not that that's hugely important to answer this specific part of the question, but if the graph is going to make sense, I think it is important. So if it decreased by 3,000 during the first year, and it's a linear relationship, that means it would decrease by 3,000 in the second year, and the third year, and so on. So it is decreasing by $3,000 per year. Okay, now we are supposed to assume that the decrease is actually following an exponential pattern. So exponential decay, I'm hoping to see something a little bit more along these lines. So it'll flatten out a little bit. Start off with really big drop-offs and then level off and not be dropping off as much. We already know that in 1 year, the price dropped by $3,000. What I would like to know is what percent increase or decrease is that. So it drops $3,000 per, well, let's just say during year 1. We're only assuming that holds for the first year this time. Okay, so what we really need is percent increase, percent decrease. And actually, I would say the easiest way to get that isn't even using the $3,000. We want to know if something started at $20,000 and we took some percent P of that and ended up with $17,000. What percent of our initial amount is 17,000? So we get 17,000 over 20,000. We can knock off a few zeros, and then I'd like a decimal here just so I can see if it makes sense. 0.85. Which means 17,000 is 85% of 20,000. If it's really an exponential pattern and over the first year it drops by 15%, then over the second year it will also drop by 15%, same for the third year and the fourth year and so on. So let's see, if we have, what is this one asking me again? What is the annual rate of decrease? Okay, so we don't have to set up a whole formula or anything. We can just say that it's decreasing by 15% per year. All right, and then actually I'm going to sneak in an extra question here. Let's go a little bit out of order. I don't think I've done one yet where I ask you to plug in. So I've done a lot of work on setting up the equations and spotting how fast things are increasing or decreasing. But in your homework, you'll see that you have questions about once you've got the equation, use it to make a prediction or something like that. So let's skip for just a minute and say, let's see, let's say how much will the car be worth after 3 years, assuming its value is decreasing exponentially. Sorry, you gotta watch me right through all of that. And then I'll come back and I'll look at part D, and hopefully I left myself enough room for that. If the car's value was initially $20,000, and that's decreasing by 15%, meaning I multiply by 0.85 every year. That was the annual. Oh, I don't know why I'm using that. Let's use Y for number of years. Okay. If we want to know what's happening after 3 years, this is let's say V of Y, where V is the value. We're really looking for a V of 3. So we'll have 20,000 times 0.85 cubed. I'll give you an approximate on that. And I get roughly 12,282.5. Okay, so dollars on that, that's the value of the car after 3 years. If its value, it continues to decrease exponentially. For part D actually ends up being a little bit more of a trial and error problem. So you have to think carefully to set it up. We can start with our same V of Y formula that we used down below. The value of the car, if it really is exponential decay, decreases according to the equation 20,000 times 0.85 to the Y. We're interested in knowing when the value of the car is half of its original curse. So we want to take this whole thing, the V of Y, and set it equal to half the original value. We've said the original value is 20,000, so we're really setting this thing equal to 10,000. You can feel free just to start your guess and check right now until we get logs, which we will shortly. To solve an exponential equation, the only thing that we can do is trial and error. So let's go ahead. Actually, that's not quite the only thing we could do. We could also graph the function, but I don't want to get too fancy with this in case it's hard for people, because shortly we will be able to do better. What do we know? We know that it goes to 17,000 after 1 year. So let's go like 4 years and see where that puts us. Oh, let me try that again. 20,000 times 0.85 to the 4th. You could also just use the times button, but I definitely type that in as 20,000.85 all raised to the 4. Okay, that's a little better, and I'm actually getting close already to 10,000. That wasn't a bad guess. It was definitely just a guess. Okay, and 5 is too far. So I think I'm going to go for the nearest 10th, and I try on a problem like this to be specific for you, but I've got my calculator right here, so it's not hard to try a little bit harder. So it's a little bit more than 4 and less than 5. Let's try a 4.3. That was a little bit too long. It's now below. It's decaying, so if it's still below, you've gone too far. Let's go 4.2. Oh. Let me try that again. No 44. 4.2. Really close. Okay, hold on. That's not quite far enough. So it's somewhere between 4.2 and 4.3 years. Let's see which one is closest. 106 off. 4.3. I would say 4.3 appears to be best. So it takes about 4.3 years for the car to decrease to half of its original value. All right, thanks for watching.